Our new unit we're going to begin today is on rational expressions. And what a rational expression is referring to is the quotient of two polynomials. In other words, we're going to have fractions with algebra in them, fractions with variables. So that brings in two things that we all love, fractions and algebra, and we bring them together. Our first section today is going to be on simplifying rational expressions, and we're going to simplify them just like a fraction. If you look at our fraction here, 12/16, when you look at that, when you learn to reduce that or simplify that, you were told to look for the greatest common factor, the largest number that goes into both 12 and 16, and divide both the top and bottom by that common factor so you have your fraction in lowest terms. Well, we're going to do the exact same thing here with variables. And you notice adding variables into the problem doesn't change what we do at all. In this case of a monomial divided by a monomial, I can look at that in the exact same way that I did on the problem above. I simply say, what number goes into both 5 and 15? Well, I can divide both of those by 5. However, I can also divide two x's out of both the top and bottom. So I get on top, all that's left is an x. On bottom, a 3, because 15 divided by 5 is 3. X squared divided by x squared is 1. So that's simplifying a rational expression. We've simply put a variable into our fraction. So that's the very basic concept we're looking at today. The concept of dividing out a common factor. In order to be able to reduce a rational or simplify a rational expression, you must be able to divide out a common factor from both the top and the bottom. This may be the most important slide that we look at in the whole year based on my experience of mistakes that people make and they carry over into future classes. So we're going to start with the bad example. Never, ever do this. Never find yourself where I say, I have -4 on both top and bottom, so I get 10x over 6x, which is 5x over 3. That is very, very, very wrong. You cannot cross something out or divide something out over addition and subtraction. And we're going to clarify that in a minute. But this is a really, really big idea. If you do things like this, you will see things like no written on your paper. We never, ever, ever do this. And you may see this look on my face if you ever do that. We never, ever cross off the plus or minus 4. It is such a big mistake there to cross off the -4 that you even make a baby angry when you do that. I mean, look at that face. You do not want to make the baby angry. So we never, ever, ever do this. We never cross off -4 over -4 and say that can cancel out. That is never, ever the case. Do not use that rule. Now, I don't know if you picked up on the last slide, but we can't cross off the -4s. What we're looking for here is we need something we can divide out of both of those terms. So in order to do that, we're going to use some of the knowledge we have on factoring. And we're just going to say, what if I would rewrite this as 2 times 5x minus 2? Because the top I can divide a 2 out of. In the bottom, 6x minus 4, I can also factor out a 2. So by factoring that out, I now have a situation where I have 2 multiplied by 5x minus 2 and 2 multiplied by 3x minus 2. So I can take those 2's out because I can divide both the top and bottom by 2. They're no longer tied in to the plus and minus. We divided out a 2 from the top and bottom, so our answer would be 5x minus 2 over 3x minus 2. that is our simplified answer. That is as simple as we can get. So make sure you're getting in the habit of not trying to divide out or cancel out over a plus or a minus. You need to be able to factor it out or divide it out of both the top and bottom. Let's look at another example. In our next example, we have 3x plus 9 over 8x squared plus 24x. Whenever I see these plus and minus signs, I'm always going to start by factoring. I'm just going to say, what happens if I divide a common factor out of the top and bottom? On top, that common factor is 3. So I get 3 times x plus 3. On bottom, I can divide an 8x out of both 8x squared and 24x, which gives me 8x times x plus 3. Now, this is the part where some people get bothered by the fact that we said you can't eliminate a plus or a minus. Well, in this case, we now have x plus 3 as a factor of both the top and bottom. So you can divide out of a multiplication. So I can divide x plus 3 out of both the top and bottom, leaving me with 3 over 8x. So what we're looking for is, we're looking for the exact same factor on top and bottom. That factor might be x plus 3. That allows me to divide that factor out. But up here, when I had my minus 4, those were not factors. Those were subtractions, so we cannot divide those out. So when we do things correctly, you notice now the baby is happy. We want happy babies. So make sure you're following your rules for simplifying rationals. Alright, so here's our steps. Here's what you need to go through the process for simplifying a rational expression. You first identify the greatest common factor of the top and bottom. We divide both the top and bottom by the greatest common factor. Then, once we've divided that out, we state our excluded values. And so the excluded values part we have not quite covered yet, so let's take a minute and look at that. An excluded value refers to this mathematical rule you learned back in probably 4th or 5th grade that says you can never divide by 0. So that rule is a huge one in all of math. We know we must follow that rule. You can never divide by 0. So therefore, when I look at this problem here that's given to me 6x cubed divided by 12x, before I can do any work with that, I need to make this statement. X cannot be 0. Because if x were 0, 12 times 0 on bottom would create a 0 in the bottom of a fraction, and that cannot happen. So whenever we simplify a rational, we want to make sure we state this can't work if x is 0. So when I divide out of both sides here 6x, I end up with x squared over 2 as long as x can't be 0. So you need to include the excluded value as part of your answer. So this right here, you notice when we did the excluded value, we do it from the original problem, not from the simplified form. Make sure you're always doing that from the original part of the problem. So let's look at one more example quickly here. I have 5x squared minus 15x. I can divide 5x out of that from the top and bottom. On bottom, I don't have any common factor to divide out, but I have that x minus 3 occurring on both the top and bottom, so my simplified form is 5x. However, to complete my answer, I have to look back at the original problem and say, what value would make that be 0? In this case, that value is x equals 3, so we say x can't be 3 because that would make the original problem be undefined. So this is our rational expressions. We're going to spend a few days simplifying. We're going to expand and make them more and more difficult as we go, but today we're going to look at the very simple concept. Divide out the common factor, reduce your fraction, and state the excluded values.